This is on balancing redox reactions, part one. I'm going to do a very simple reaction that'll help you to do more complicated ones. And so I'm going to try to balance this reaction. And at first look, it will look like it is balanced because there's one aluminum on each side and one magnesium on each side. But the charges are not balanced. The aluminum up here is +3 and the magnesium is +2. Our charges on every reaction must balance. There must be the same charge on each side of the reaction. And the first step is to figure out what's changing oxidation state. And in this one, it's pretty easy. The aluminum's going from +3 to 0, and the magnesium's going from 0 to +2. And so I write those as half reactions. I just write the aluminum down. Aluminum +3 yields aluminum. And that's a oxidation or a reduction. And so we look at it and it's gaining electrons, so that is a reduction. And the magnesium solid is going to magnesium +2. It's losing electrons, so that is an oxidation. The second thing to do, and this is not important in this one, but we'll do it, we'll make sure the metal, the element changing oxidation state, the aluminum is balanced, and it is, and the magnesium is balanced. Sometimes that's not true on that, but you need to check. Okay, and then finally we're going to balance the charge. And so I have a +3 on this side, aluminum +3, and aluminum over here is 0. Now the only thing I can do is add electrons. I can't add any positive charges anywhere, so I can only make one side more negative, so I'll have to add 3 electrons, each of them -1. That will total up to -3 +3 on this side, which is 0. And that's what we have over here. And you should already be writing down +2 electrons on this side. I will have 0 over here and 0 on this side. It doesn't have to be 0, it just turned out that way this time. We'll do some where there's not. Now I add the reaction, so let me rewrite so we can mess it up again. And I gotta add these so that the charges cancel. So we're going to treat this as an equal sign. Okay, think about the arrows as equal signs, and I'm just going to add 2 equations. It's one way to think of it. And what I need to do is I need to add them so that the electrons cancel. So this top one, I'm going to multiply by 2, making a big deal out of that. People mess this up. That will give me 6 electrons, and I multiply by 3 over here, and that will give me 6 electrons because 2 times 3 is 6, and 2 up here times the 3 here is 6 electrons. So I do this addition and multiplication at the same time. Here we go. 2, don't forget about it, times everything. 2 times 3 is 6 electrons. 2 times the aluminum +3 is 2 aluminum +3, and I got 3 times the magnesium, and then I have my equal sign, and I get 2 times the aluminum on the top right here, and I have 3 times the magnesium and 3 times the 2 electrons, so I get +3 magnesium, +2, and +6 electrons. Very important, you don't drop charges. Now if I look, my electrons cancel, and I can rewrite this as 2 aluminum +3 +3 magnesiums yields 2 aluminum +3 magnesium +2. Very simple. That's it for this video. I'll make another one for the next one, which is more difficult.